Hello guys! I'm coming back very quick, right? Okay, so we need to shift to another topic. Sorry, I really missed chemistry. Okay, you get the point? So my world is gonna be like studying pure science, English language, like that, health topics, and various topics that interest me the most. Okay, or OSH, occupational safety and health. But this time we're gonna be talking, and I'll be able to elucidate basic concepts of chemistry. Okay, so first thing to do is we need to define chemistry. Anybody? Okay. What is chemistry? Okay, so chemistry. Okay, chemistry. Okay, so it's a branch of pure science. Is a branch of pure science. Okay, I may write so that we will not forget. It's a branch of pure science. Okay. You can pronounce it as a science or science. It depends on you, huh? Okay. Okay. That deals with the study of what? That deals with the study of matter. Okay. Matter. And take note for the nouns and the verbs. Okay, and the changes it undergoes. Okay, there's a lot of definitions for this, but it looks like complex. That's why when I was in high school, I really memorized the most basic to understand. And I will be the one to beautify the grammar. Things like that, okay? Changes it undergoes. It talks like composition like that, or different like that. Properties, blah, 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 so on. So, but it means the same thing with this one straightforward definition. Okay? The point. Okay, sometimes it talks about the mixtures, blah, 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 substances, compositions. But to avoid too much talking on that, you get the point. So, too much verbosity, so we need to curtail the words, okay, or reduce the words, okay? Okay. Chemistry is a branch of pure science that deals with the study of, so, keywords, matter, okay? Or matter also is a homonym. Matter as a substance or substances, and matter also that, for example, as a matter of fact, this can have, it can be used in English, meaning to say main topic, main heading, main context, like that, right? Matter and matter, okay? So different meaning, different pronunciation. Oh no, the same pronunciation but different meaning, sorry. But the same spelling. What's that? The same spelling, different meaning, and different pronunciation. It's gonna be a homograph. Sorry. To the point. Okay, so okay, undergoes. Undergoes is also an action verb, huh? This is not quite used most of the time. For example, I will undergo my dinner, okay, because I'm very hungry, okay, I'm starving, things like that. The point, so it looks like a dance to use this action verb. Undergo, undergoes, and underwent. For example, I underwent my surgical operation last 2 months ago. It was not painful. I really survived up to now. Things like this. So underwent is the simple past form for this. Past simple form of undergoes. Okay? Like that. So, having the definition itself is an active. Okay? Active. Active statement. Okay? Or active voice. Okay? Like that. We have also the active voice, passive voice. Okay, or passive statement, okay? So your identification really, if we talk about passive and active, so passive will be more on the related to the past. Okay, you got the point, but active related to the present. To make it simpler in our understanding. Okay, you got the point? Things like that. So here it's very active, right? Okay. Active statement. Okay, so we have active verbs and passive verbs like that. Okay. Now here is a branch of pure science that deals with the study of matter and the changes it undergoes, right? Okay. So matter. So we need to define matter. Okay. Matter is anything that occupies space and has mass or weight. It depends on you, okay? So let's calibrate that into weight. It's preferably more accurate rather than mass. Okay? But actually, it has this meaning. It depends on how you justify your answer. Okay, but to make it simpler, we will use weight. We will consider the gravity. Okay, get the point? Things like that. Okay, matter is anything that occupies space and has weight or slash mass. Okay, and then undergoes, then changes. Okay, changes noun. Okay, plural of change, right? Undergoes, plural of undergo. Okay, like that. Okay, matter is uncountable noun. The plural and the singular will be just the same. There's no matters. Okay, in the other aspect. But there's a matters also when you use that in the utilization of English. Okay, say it matters a lot. Okay, so it depends on how you use the sentence, but you know, in normal sense of using this, so the plurality will not be used most of the times. Okay, especially in science concept, you will never say matters. Okay, again, in the context of science, you'll never use matters. Okay, but in the context of English language, you can use matters. It depends on your utilization of your noun and verb agreement on your sentence. You get the point? Okay, for example, you will say, oh, you know, love matters a lot. You will never say also, love matter, wrong grammar. Okay, so that's why in English language, to add plurality is very important. But here in science, we need to say, is a branch of pure science that deals with the study of matters. Because you said there's a lot of substances. Okay, you get the point? You get the point? Because matter is singular in the appearance here in the whiteboard, but it's plural also if we use the word substance. It will become substances. Like that. Why? Because matter have three phases. We have not the phase in our head, but the phases, P-H-A-S-E-S. We have solid, liquid, and a gas. Okay. Now, to avoid confusion, so that we will not be bewildered and be perplexed and be confused in the obscurity or of the utilization, so that it will not become ambiguous, to avoid ambiguity, then we need to say phases, okay, forms, okay, we have also states, okay, like that, okay. So three phases of matter, three forms of matter, three states of matter, okay, and three substances of matter. So this will be correct all. So these are all synonyms and semantics, the same meaning. Okay, that's why in science sometimes it will be, used interchangeably. You will be wondering why you are memorizing phases, but when you have an examination, it will be changed to forms. There's a little bit of trick and trap during the examination, right? Because you love to memorize plainly, but you forgot the vocabulary. You got the point? So, three phases of matter: solid, liquid, gas. Three forms of matter: solid, liquid, and gas. Three states of matter: solid, liquid, and gas. Three substances of matter: solid, liquid, and gas. Okay? Copy? Okay. So, now, we will talk about, okay, no changes, right? Before, changes is very important. Wait, okay, things like that. The only constant in this world is change. Do you know that? Okay, so the world is always changing, right? According to its phase, time, and space. Wow. When I say phase, don't take phase as a literal. For example, phase like a land, a soil, water, atmosphere. That's also phases. Okay, but do not limit your word phase because of the face of your head. You get the point? So this is vocabulary all about. You don't need to be literal and word for word in understanding. You need to go to the tip of the iceberg. Then you will use the submarine underwater to understand rather than the ship and the boat that's already in the surface of the water. Sorry. Okay? That's knowledge. You need to go down. You get the point? So, not on the shallow. You get the point? So, it's gonna like that. Okay. So, okay, changes. What are the two types of changes? Okay. What are the two types of changes? This is very easy. We have the physical and the chemical. Okay. Physical and chemical. Okay. Like that. Only two. You don't have to put biochemical, biophysical. Okay, you don't have to add more. Get the point? I know these are also changes, but we are referring to the basic changes. Okay? You got the point? Basic type of changes in chemistry. Physical and chemical. Okay? You got the point? Physical, there will be, okay, chemical first. There will be an alteration of the form, okay, or the composition. What do you mean by alteration? Okay? Alteration. Okay, so what are the other synonyms of alteration? Meaning it has been destroyed. Okay, it has been annihilated. What else? Things like that. Okay, actually there's a lot. Okay, so alteration of form or appearance. Okay, like that. And then changes of the smell, odor, and especially sorry, color. Okay, like that. Get the point? So that's chemical. And most of all, it involves chemical reactions. Okay. Chemical reactions. Okay. So meaning chemical changes. Okay. Then physical. What is physical? There's no alteration of the form. Okay, get the point? Things like that. Okay, and then usually behave naturally without adding artificial activities or tasks. Things like that. You don't have to use your hand to do that, like blah blah blah, so and so. You will use your hand, but actually it will never change the form and appearance. Okay. For example, from solid to liquid, blah blah blah, so and so, like that. Okay, but it refers to the temperature, pressure, like that. Okay, physical properties based on physical properties. Okay, you get the point. But you know, it's very difficult to discuss in an elementary discussion and in a complex discussion kasi because in our elementary we are taught that physical is only just like cutting the trees, and you know the trees will be not decomposed, but it will change the dimension or the size of the trees, it will become smaller like that. That's the definition in elementary. Okay, but in complex, it would be the same. It will be a little bit difficult. Physical change meaning based on physical parameters like the blah blah blah, so and so. We get the point. Okay, like pressure, like that. You get the point. Okay, like volume, like the number of moles, things like that. You get the point. Okay, things like that. That's chemical only. Okay, got the point. And then your key indicator for chemical, there must be a concentration. Concentration changes. Okay, like that. You get the point. If you change the temperature, my friend, wow. Okay, it will never be a chemical change. Okay, if you change the pressure, it will never be a chemical change. Okay, but if you change the concentration, it will become a chemical change because it is having the chemical reaction or the reactivity. You get the point? Okay, that's changes. You get the point. So it's better for me to give examples, but our discussion will take longer time, right? You get the point? See, the 2 hours and 3 hours will not be enough to discuss everything about physical changes, chemical changes, blah blah blah. Okay, that would be enough, right? Based on the physical parameters or physical properties. Okay, things like that. So let's erase this one. Okay, so we need to say you can use also your hand. Okay, but most of the times there will be no color changes. There will be no smell changes or odor changes like that. Okay? But sometimes also have kasi, that's why it's very difficult to make it general. Okay, you get the point? Okay, in higher science, there will be an exemptions. But for the purpose of discussion, let's go to the basic. You get the point? Things like that. Okay, so for example, distillation, what's that? Chemical change or physical change? Oh. Liquid extraction, that is chemical change or physical change. Maglibog din. Ano? Okay, get the point. So, evaporation is a chemical change or physical change. Oh. Condensation, physical change, chemical change. Oh. So, if we try to, consider the basic concept, it's very easy to extract. Physical based on parameters. What are those? For example, according to its density, according to its boiling points, because distillation is a separation process based on the difference in their boiling points. Okay, that's distillation, right? So we have the distillates, and the other one is the product or the condensate, things like that. So it's gonna be physical change. You get the point? But for all chemical reactions, that would be chemical change already. What are those? For example, decomposition. Okay. Decomposition. Okay. Number 2, single replacement and double replacement. Combustion. Incomplete combustion or complete combustion. Photosynthesis. Okay. Why include photosynthesis? Okay, because it adds the light energy to convert into chemicals, things like that, the glucose primarily. And then there's also phosphorylation reaction also by the phosphorus, okay, given by the sun. You got elemental phosphorus coming from the sun. That's why it will generate like glucose and everything. Okay, in our elementary science, okay, our teachers will never taught us that there will be phosphorylation, like this. But if you go to advanced study, for example, in BS chemistry or chemical engineering, things like that, or nuclear engineering or whatever, or petroleum engineering, so we are taught, no, it's not all. Okay, we are taught that after the photosynthesis in the sun, there will be a phosphorylation reaction. Okay, by the addition of phosphorus. Okay, so that it will yield a glucose. You get the point? Things like that. That will be our basis. Okay, and then the chlorophyll coming from the plants. Things like that. Okay, so That's why it's very, very important. You get the point? Ganon. Okay. So wait. Sumunod na siya, no? Atom chemistry. Now, oh my gosh. Okay. So let's erase this. Okay. Since talking about matter, we need to go first with the solid substances. Okay, so the very basic is we need to elucidate in terms of alkalinity. What do you mean by alkalinity? We keep on reading books like that, and we keep, exposing ourselves to the terminology alkaline solution, like that. What is really an alkaline? Okay, because we keep on using that, and we don't understand what is that all about. You get the point? Because others are used that frequently, and then we are also using that one, but we don't know really what is that. Okay. So, alkaline. Okay, alkaline. Okay, alkaline is the same as basic, things like that. The pH will be above 7. Okay, pH above 7. So this is alkalinity. Okay, for example, in order for the human being to survive, at least the pH of our blood is alkaline, not acidic. Because if our blood pH is acidic, then all of us will die. Because we cannot manufacture the right red blood cells and the appropriate hemoglobin, okay, for our survival, for our, blood flow circulation. Get the point. It's at least a pH of 8.9 to 9 something, things like that. You get the point? Okay. Because come to think with this very logic. Okay, if our blood is acidic, then why virus will come to our immune system? Okay, so they will die supposedly. Then why the virus will come into our system? Because our blood is not acidic. You get the point? So automatically they will die. There will be no COVID. We don't need to eat highly acidic fruit. Okay, for example, the pH of 2.2, like lemon. Okay, because lemon is very powerful in our immune system to help kill this viral or viruses or things like that. Okay, get the point? So what if our blood is acidic, right? So there's purpose for that, because if our blood is acidic, then we are not healthy. We cannot manufacture, we cannot produce other synthesis products inside our body during the biochemical reaction, because most of the biochemical reactions inside our body, like for example, producing lipid, fat, protein, amino acids, our DNA, our RNA, ribonucleic acid, things like that, okay, are not really acidic in nature, okay? So if that is the case, then we all will die. Because our blood is acidic, then all people will have leukemia, like that, because the red blood cells will be eaten by the white blood cells. Too much level of the leukocytes. Leukocytes meaning white blood cells. Okay? So that's why like that. Okay? You get the point. So, alkaline, pH above 7. Okay, you get the point. Okay, so alkalinity has special utilization. Mostly, you will use that in biochemical reactions, talking about, disease like that, blah, 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 so and so. You get the point. And another explanation of alkaline, it will produce hydroxides in solution, or OH. The same with basic, right? But the most precise term kasi is alkalinity. Okay, not basicity. You get the point? But in chemical reactions, we mostly use the basic rather than alkaline, right? First of all, neutralization reaction is the addition of acid and the base to produce salt and water. You will never say it's an addition of acid and an alkaline to produce salt and water. You get the point? It depends on your utilization also. So for example, so we have alkaline earth metal. Okay, alkaline earth metal. Okay. Without alkaline earth metal also, all people will die. Okay. Nobody can exist without alkaline earth metal because most of these are minerals for our survival in our health. For example, sodium, potassium, like that, blah, 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 so and so. Without sodium, we will die because we cannot produce an electrical impulse for our neurotransmitters in our brain cells. Okay, to let us think, to let us decide something, to make our plan of the day very fruitful and productive, to eat, to walk, to pray, to dance, to sing, everything we move, there must be an electrical impulses, okay, brought by our neurotransmitters and our hormones. Then that is the regulation between the sodium and the potassium. Oh, see, if there's no sodium and potassium, then all of us will die. Okay, that's why we need to eat banana, good source of potassium. Banana also is very powerful also to make us smart, not only for the bone health, huh? Okay, things like that. Okay, so it's gonna be alkaline earth metals. What are those? Oh my gosh. Okay, it starts with a very popular Be. Oh, diba? Okay, Be. Okay, what is Be? This is beryllium with atomic weight of 4 approximately grams per atom. Okay, beryllium. Okay, things like that. Okay, who discovered beryllium? Okay, who discovered beryllium? If you love chemistry during your review in the board examination, if you can still remember, okay, but in high school I already memorized these scientists. Okay, but for you, if you can still recall, who discovered beryllium? Okay, things like that. Okay, this is covered by Antoine Bazet. Okay. Sorry guys, because I love memorization and study when I was in high school and college. Okay, Antoine Bazet. Okay. We have Nicholas Vauquelin. Nicholas Vauquelin. Okay, Nicholas Vauquelin. Okay, this will be useful to have your stock knowledge so that you will never Google search anymore. Okay, you get the point. And then we have also Friedrich Wöhler. Wow, amazing! There are 3, persons who discovered this beryllium. Actually, they are scientists. Okay, Friedrich. Okay, Wöhler. Okay, so in your memorization technique, very easy to memorize persons here are Nicholas, right? And Bazet and Friedrich. So when you try to register that in your hippocampus part of your brain, okay, which is in the cerebrum vortex part of our central nervous system, then you need to see, oh, Bazet, from the word bus, transportation bus. Like that, oh, Bazet, oh, okay, Antoine Bazet, oh, things like that. You will walk like that, going to canteen, Bacala, you will still remember Antoine Bazet, like that. Okay, but you will play only in your mind. It looks like you are crazy, but you are inputting knowledge. You get the point? So, if you really want to have a brain power, okay, you don't be bothered with anybody else saying negative to you. Even to the extent they will say that you are fool, you are crazy, things like that. Never mind, okay? Ignore them all. If you want to enrich and enhance your brain power and cognitive ability. Okay, things like that. So, Antoine Bazet. Okay. Oh, this guy also Nicholas. Okay. Nicholas Vauquelin. It looks like very strange, the Vauquelin, but I love it. Vauquelin. Wow. Okay. Nicholas is very easy to remember. Okay, Nicholas, let's try to think that there's gonna be a Nicholas Street in Cebu City. Okay, oh, Nicholas Street, Cebu City. Oh, you're gonna remember now. And then Friedrich Wöhler, it's gonna be like Friedrich, frying at the same time rich. So fried and rich. So Friedrich Wöhler. Oh, okay. So you can still remember these three. So it's gonna be the way of how to have mechanism in your memorization. Okay. Now this is done in 18th century in 1828. Okay, like that. 18th century in 1828. Now, these three personalities, okay, isolated beryllium in different experimentations, but in the same year. They are doing this independently. You get a point, not simultaneous in the laboratory. They experimented individually and they isolated beryllium in their experiments. Individual experiment and with their experiments. Plurality and singularity. It's very difficult, right? When you're speaking, you maintain the grammar accuracy. It's very difficult, really. Okay, get the point. So things like that. Okay, again, who discovered beryllium? Antoine Bazzi, Nicolas Vauquelin, and Frederick Schuyler. Okay, so you can remember these things because it will come out sometimes in the chemistry competition like that or quiz. Okay, things like that. Okay. And then, prior to these three personalities, we have also this another scientist who is very popular. He's a chemist. I think he is an English chemist. English chemist meaning from England. You get the point? Things like that. Or I'm not really that sure. Based on my stock knowledge, I think he's a German. Things like that. Sorry guys if it will be mixed up because I don't Google search. You get the point? Things what comes on my brain, I really discuss. That's why I keep asking you, please correct me if I'm wrong. Things like because there's no perfection. This is just fact knowledge. Okay, get the point? Things like that. Prior to this, we've also 1807, right? You can still remember this. Okay, I think so. And 1808, 18th century. So you will remember this, guys, that most of the alkaline metals and alkaline earth metals were discovered in 18th century. Okay. Right, so 1807 and 1808 is gonna be Humphrey Davy. Okay, Humphrey Davy. Okay, the spelling is Humphrey Davy. Okay, so he isolated first the sodium and potassium by his experiments. Okay, if the question in the future will say, who discovered sodium? Okay, your answer will be Humphrey Davy, automatically, without question. Okay, you get the point. So, sodium, potassium. So, we will be thankful to Humphrey Davy. Without Humphrey Davy, we will never experience what potassium all about. Okay, and potassium is good for our bone health. Right? Okay, things like that. Okay, and sodium is good for the production of our digestive acid. Okay, hydrochloric acid to maintain the digestive health of our gut, GUT, or our digestive system. Okay, or the secretion of pancreatic juices from the pancreas also, right? Get the point? So sodium, potassium. In 1808, he discovered the strontium. I love it. Strontium, barium, okay, calcium, and magnesium. Okay. For all scientists in the entire world, basing in the past and to now, it is only Humphrey Davy that discovered a lot of elements. Nothing else. Okay, if you can remember a certain scientist or a specific scientist that discovered a lot of elements in the periodic table, it's going to be Humphrey Davy. Because he discovered 7 elements during his experimentation. Okay, things like that. So, strontium, barium, calcium, magnesium. And then the last he discovered and isolated in his experimentation, the boron. Okay, boron. Oh, boron, what's that all about, sir? Boron. If you can still remember boron, it's also in the alkaline earth metals, right? Remember? Wait. Let's enumerate the alkaline metals and the alkaline earth metals. Okay, review. In 18th century, 1807, Okay, Humphrey Davy discovered sodium and potassium. And after 1 year, he also discovered 1808 sodium, barium, calcium, magnesium. And after that a little bit, but it's still in 1808 also, but the last discovered element by Humphrey Davy will be boron. Okay, so if the examination will say enumerate and list all the elements discovered by Humphrey Davy. 1 to 7, fill in the blanks. So you can answer now, sodium, potassium, strontium, calcium, magnesium, and boron. In your theories and principles scores, then you will get a very high scores in theories, principles, and concepts. Okay, because the examination will always like that. Theory and calculation. So mamuhunan ka sa theory so that it will be raised your score. Okay, because to tell you honestly, it's gonna be more on the theory and principles. I think it's gonna be 70% up or 60% up, play around like that, and you have to add only a little bit to the calculation, then bingo, you will pass the examination. If you are good in principles and concepts, basic foundation. Okay, things like that. Okay, even though you are not really that good in math, trust me, okay? Because I don't like math also in the first place, but I am just average. Okay, get the point? Because it's a wrong concept and a wrong philosophy that they say, you will never become an engineer if you're not good in math. But I'm not good in math, then why I become an engineer? Right? So it's not like that. We should not generalize things. Okay, get the point? Things like that. And then why I can speak English well? I'm an engineer. They said most of the engineers cannot speak well in English. Things like that. Okay, so we don't generalize thing. You got the point? Okay, so beryllium, sodium, potassium, strontium, barium, calcium, magnesium, and boron. Oh, I love it. We have the caustic soda. Okay, so sodium hydroxide, right? Caustic soda and sodium bicarbonate. Oh my gosh, for making the bread, pastries like that. Oh, see, without also that, then we cannot eat the food. Okay, so that's why we are made of chemicals. People are made of chemicals. Without chemicals, we will die. Okay, and that's very clear. Without oxygen, we will die, and oxygen is an example of a chemical. Okay, because chemical is positive and good. If you try to really study chemicals, it's not only bad. Okay, we need to change our perspective with regards to the deep understanding of what is really a chemical all about. Okay, it's good and bad actually. Okay, get the point. So the moment God will take out your urine, you also die, and urine is composed of chemicals. The urea, okay, CH4N2O. Okay, 1 atom of carbon, 4 atoms of hydrogen, 2 atoms of nitrogen, and 1 atom of oxygen is the chemical composition of our urine. Get the point? Then early in the morning, we will urine. And then if you try to experiment or list all the chemicals, carbon, hydrogen, nitrogen. Thank you, Lord. Diba? Things like that. So, if we treat every second, every minute, every hour as highly scientific as it is, then bingo, we can understand really that we are made of chemicals. Okay, get the point. Yes. Okay, things like that. Thank you so much for watching this basic chemistry. I'll be coming back. I will be able to teach you about the difference between nitrous oxide, dinitrogen oxide, and dinitrogen monoxide. Okay, what's that all about? Okay, is this a greenhouse gas or not? That can contribute the change of our weather, that can really have an alarming effect to our, climate. It's gonna be the climate change or not? Things like that. You get the point. So see you later. If you have comment down below, then you can comment anything. And then you can correct me if I'm wrong, because I'm just human that commits mistake. There's no perfection in this contemporary world. And if you can subscribe also my YT channel, then I will be grateful. Okay. And I will extend my happiness to the heaven. Okay, thank you so much. Remember this, that Jesus loves us. Thank you so much. Bye bye. God bless everybody.